I think the coolest skill or the most important skill is really to be tenacious, to be stubborn. That's what I want in my students. I want them to get challenged and not give up. I want them to approach a problem like two linemen in a football game. I want them to fail and not give up and get up, brush themselves off, and try again. I really think that being stubborn is the best skill that a mathematician can have.
Oh, that's simple. In computer science, to be able to program, and in mathematics, to be able to compute. And those two go together because a lot of computation today is done using computer software. But you have to know how to program the computer to use the software to do the computation. So computer science and mathematics go together hand in hand.
Understanding why things work. It turns out that, programmers program computers, right? But a lot of the reason we do that is because computers are simple enough that you can actually understand them. You build systems as a programmer. Systems are just a bunch of moving parts that have rules and actions and so on and so forth. It turns out the whole world's made out of that sort of thing. There's systems to driving a car, there's systems to how a business works, there's a system that does everything. And once you start learning how to think about systems, you start seeing them everywhere. Once you start seeing systems everywhere, you start understanding how things work. And once you understand how things work, you can understand how you fit into them and how to get them to work for you. So the world becomes, honestly, it's like a whole other dimension.
Okay, so here's something that when I learned how to do it, I didn't think was really mathematical, but it is. I've got a string like this, and I learned this when I was about probably 7 years old or something. So, I do that, and this, so I'm making something with this string called Jacob's Ladder. And so it looks like it's just a whole bunch of knots, but it's not. It's the unknot, so that's the unknot mathematically.
So one of my favorite things that I've been working on the past year is solving a Rubik's Cube, and you can actually figure out a solution using math, especially algebra, abstract algebra, which is one of our 300 level classes we offer. And you can kind of keep track of all the different moves you can do with Rubik's Cube through algebra and work on a solution for it, which I think is awesome.
Probably more than anything, it's to communicate how to get insight from data in context. And that, more than anything, is what the discipline of statistics is all about. It absolutely is not, as is stereotypically thought, just a matter of manipulating formulas or counting beans or making graphs and charts. I mean, for the most part, you relegate that kind of mindless activity to technology and focus on what's more important, namely, what do all those analyses tell you about whatever you're trying to study? So it's learning how to get insight from data in context that is the crucial, most important skill that a statistician can